So we have a fully enclosed building with the wind blowing on its side. We are to calculate the internal pressure on the roof and internal and external pressure acting on the roof of this building. To solve this, let's tackle by first of all solving for the windward side of the roof. And we know that we could use our, first of all, we need to calculate our velocity pressure. And the reason why I'm saying it, because to calculate our the external pressure on windward side of the roof, we have to use our formula wind velocity with respect to mean height times our gust effect factor times our roof pressure coefficient. And we know that we don't have our velocity pressure here. Yes, so to solve velocity pressure, we know the formula, which is 0.00256 times our velocity pressure exposure coefficient times our topographic factor times our wind directionality and times velocity squared. Another thing, for this problem we have to remember that our velocity for this problem will be 105 miles per hour. It's not given in this, but this is the default velocity for this textbook. So to solve this, we now have another problem. We have to calculate our velocity pressure coefficient, exposure coefficient. And to do that, we need to know our mean height, and we are not given our mean height. So let's calculate our mean height. So our mean height is 15, the wall height, plus the height of the roof, or the highest point of the roof, which is this here. And looks like we'll have to use tan. And I'm dividing it by 2 to get our mean height. And this would come up to 17.204 feet. Alright, we have got that, but now we have another problem. Because our velocity pressure exposure table here doesn't have this value for a mean. So therefore we'll have to use linear interpolation to solve this problem. So we know from linear interpolation that our height above ground is equal to our mean height. To solve this, first of all, we need our velocity pressure coefficient for 2 points in our slope, and these 2 points should be where our needed point is in the line. So that means it'll be 0.9 take away 0.85 divided by 20 feet take away 15 feet equals to our 0.95 for our exposure coefficient, take away our exposure coefficient that we are looking for. And now this divided by 20 take away 17.204. Now let's simplify this. So we know 0.9 take away 0.85 would become 0.05 divided by 5 equals to 0.9 take away exposure coefficient, and 20 take away 17.204. This becomes 2.796. And now we cross multiply these values, and we get 0.1398 equals to 0.9 times 5 becomes 4.5 take away 5 exposure factor here. Okay, now we have to simplify further, and our exposure coefficient should be 0.1398 take away 0.45 divided by 5, and we get positive 0.8720 as our exposure coefficient. Oh, and pardon me, I was using the wrong symbol. It's KZ, and KZ. Okay, so now this equation we should be able to solve this equation with 0.056 times our exposure coefficient, which we just found out, times our topographic factor, which is 1 because it's an open area, times our directionality, because we know just we're thinking about or solving for just wind in this problem, and our velocity 0.105 squared, and solving this 2.56 times 0.8720 times 105 squared, and we get answer to be 24.611 pounds per square foot. Okay, now that we have our velocity factor figured out, we can go back to our velocity pressure figured out. We can go back to our design pressure equation once again, and it looks like we are missing another part here, and that's our roof pressure coefficient in order to solve our design pressure equation here. So let's write this equation first of all before we do anything. So we know that our velocity pressure we just found out, and we know that our gust effect factor would be 0.85 because it's a rigid structure. And now we have to find our roof pressure coefficient, where our H over L is greater than 2.5 but less than 0.5. So what we have to do is we have to use our linear interpolation once again in order to solve. So let's do that. So it'll be a similar idea where our to what we did earlier for our velocity pressure coefficient. So we have delta exposure coefficient, roof pressure coefficient divided by our H over L equals to delta roof pressure coefficient divided by delta H over L. So it will be negative 9 take away negative 0.7 divided by 0.5 take away 0.25 equals to 0.5, sorry, not 0.5, my bad. It's negative 0.9 take away our roof pressure coefficient divided by 0.5 take away our H over L, which is this point here, so 0.3441. Okay, and let's simplify first of all. So this would become 0.2, negative 0.2, this would be 0.25 equals to negative 0.9 take away roof pressure coefficient divided by 0.5 take away 0.3441, and this comes up to 0.1559. Okay, and now we can do our cross multiplication. This becomes 0.03118 equals to 0.9 times 0.25, negative 0.225, take away 0.25 exposure coefficient, and solving this we should be able to get some sort of good answer. Divided by 0.25, and we get negative 0.7752. Now that we have our roof pressure coefficient, we can further solve this problem. So that's 0.7753, and solving for this 0.85 times negative 7 point. Oh man, I just cleared everything on my calculator. I have to re-enter everything. Okay, and this comes up to negative 16.218 pounds per square feet. Okay, so this is our answer for our windward side of the roof, and now it's time for our leeward side of the roof to be solved. So solve the leeward side, it's the similar idea. So we'll be using our design pressure formula again, with all values being same except for our roof pressure coefficient, which would be different based on our table here. So we know that we have to use our linear interpolation once again in order to solve this problem once again. So it'll be negative 0.5, negative 0.3. It's actually repetitive. You can skip if you like, or you can continue to work with me. So 0.5 take away 0.25 equals to negative 0.5 take away our roof exposure coefficient divided by 0.5 take away our value here for our mean roof height, so 0.344. And once again, we have to simplify, so it becomes 0.2 divided by 0.25 equals to negative 0.5 equal to roof exposure coefficient. And now 0.5 take away 0.344, it becomes 0.156. All right, and now we just do cross multiplication real quick. So it is 0.0312 equals to 0.5.25, and it becomes negative 1.125, take away 0.25 exposure coefficient divided by, oh, never mind, there's nothing to be divided here. Okay, and now we solve for exposure coefficient. So 0.035 plus 0.125 divided by 0.25, and we get our exposure coefficient to be 0.6248, which seems to be a weird number. Okay. Okay, let's go back to our calculation and see where we made a mistake. Look, this looks like we have a mistake here. So 0.5 day plus 0.3 is no, I see. So this is negative. I missed a negative sign here. Okay, so now if we solve this from here, we should be able to get a good number. So 0.2 times 0.156, we get negative 0.0132 equals to negative 0.5 times 0.25. We get negative 0.125 plus negative 0.25 times our exposure coefficient. Okay, and now solving for exposure coefficient, we should get something really nice, or at least that's what I hope for. By 0.25, and we get negative 0.3752, and this looks better. Okay, so plugging this value into our equation here, 0.3752, and solving this on our calculator real quick, and we get value negative 7.849 pounds per square foot, and this is our leeward side roof load. Okay, now what we are left with is just one problem. We have to find our internal pressure for this roof, and this is actually super easy. So our design pressure formula for internal pressure of this roof is our velocity pressure times our internal pressure coefficient, and notice how I'm writing it in bracket, because for every enclosed there is a criteria I'm not going to discuss because it's going to take a little time, but basically for if a certain building meets a criteria, then its internal pressure coefficient would be plus or minus 0.18. Okay, so we already know our velocity pressure coefficient, velocity pressure, and we know that our internal pressure coefficient is 0.18. And solving this, we know that our answer for internal pressure would be plus or minus 4.43 pounds per square foot. Okay, and that's our final answer.